Hello, and welcome to this video on compound interest. We had that Red company invested $20,000 in a fund that was earning interest at a rate of 2% compounded semi-annually. After 2 years and 9 months, the company transferred these funds to another investment that was earning interest at 4.5% compounded monthly. Question A is, what is the balance in the fund at the end of 2 years and 9 months? Question B is, what is the balance in the fund at the end of 6 years from the initial investment? And C, by what amount did the fund grow during the 6-year period? And we need to round answers to the nearest cent. To work with this problem, it's useful for us to remember the future value of money written in terms of compounded interest. We have that the future value of an investment equals the present value times 1 plus I to the n, where I is the interest rate per compounding period or periodic interest rate, and n is the total number of compounding periods during a term. For part A of this problem, the term is given by 2 years and 9 months. So 2 years and 9 months. The time period is the period during which the interest is calculated, and it's always converted to years. So here we take those 9 months and we convert them into years by dividing mine by 12. So we have 2 plus 3 divided by 4, or same thing, 11 over 4 years. That's the term. Now, we have that the fund was originally earning an interest at a rate of 2% compounded semi-annually. That information tells us that we have that the periodic interest rate, the I, those 2 years and 9 months that the fund was in that fund, is given by the rate that we see, the 2% divided by 2. We take 0.00, or better, 0.02, and we divide it by 2, we get 0.01. Okay, so that will be the interest rate per compounding period. Now, for part A, we need to know n. Then to find n, we use a formula that is very useful that tells us that the total number of compounding periods during a term is calculated by multiplying the compounding frequency by the time in years. So n equals the compounding frequency multiplied by the time in years. Time period we're talking about in years. And here the compounding frequency is 2 because interest is earned at a rate of 2% compounded semi-annually. And the time in years is 11 over 4. So we have that n equals 11 over 2. Then the future value of $20,000 will be 20,000 multiplied by 1, or 0.01 to the 11 over 2. And we can use a calculator to round this quantity off to about 21,125.04. So therefore, the balance in the fund at the end of 2 years and 9 months was about $21,125.04. Okay. Now, the balance, to work with part B, we need to work with the number we just got. The balance in the fund at the end of 2 years and 9 months becomes the present value for the next period. Let's keep the value we just got in mind. Let's work with part B of this problem to see what happens with the money after 6 years from the initial date, the initial investment. So for part B, now we start with that amount of 20,000 times, and I missed a 2 here. So that's going to be the value of the investment after 2 years and 6 months. And let's see what happens after the rest of the time passes. So if 6 years pass from now and 2 years and 9 months pass first, then we have that the remaining time is 3 years. The remaining time period, we need to account for 3 years and 3 months. You know what happens 2 years and 9 months into the timeline? Now we need to know what happens after 3 years and 3 months pass. So in total, 6 years have passed. That remaining time period can be written in terms of years as 3 plus 3 over 12 years. In other words, that's 13 quarters of a year. And now we have that period of 3 years and 3 months. Interest is compounded at a rate of 4.5%, and it's monthly. Here we have 4.5% compounded monthly. And that corresponds to an I that is given by a quotient. So we take this 4.5%, that 4.5%, and we divide it by 12 because now the compounded period is monthly. So the compounding frequency is 12. And when we divide 4.5 by 12, we get 0.00375. That's our new I. Our new N is the total number of compounded periods during the second term. And it comes from multiplying the compounding frequency by the time in years. So I have the same formula we had before. Here the compounding frequency is 12 because interest is compounded monthly. And the time in years is 13 over 4. So n turns out to be 39. Interest gets compounded 39 times when 3 years and 3 months pass. So then the future value of 20,000 that we had at the beginning will be the future value of this amount that we have after 2 years and 9 months. After 3 years and 3 months pass, we have 20,000 multiplied by 1 plus 0.1, 0.01, and 0.0075, the new interest rate per compounding period, to the 39. And when we use a calculator to compute this quantity, we find that this is about 24,445.24. So there we have that. That's the answer to part B. And then to answer part C, we see that after 6 years, those 20,000 have grown into 24,445.24. So the fund grew about $4,445.24. The difference between the future value and the amount invested gives us the interest. The fund grew by about $4,445.24. All right, that's the end of this problem. So, summarize what we did. We can say the following. We created a timeline. So the time span is 6 years. After 6 years, the 6 years from now, here we have now, we have that an initial amount of $20,000 was invested in a fund that was earning interest at a rate of 2%, compounded semi-annually. But after 2 years and 9 months, the company transferred the funds to another investment that was earning interest at a different percentage, compounded monthly. Then to know how much money there was in the fund after 2 years and 9 months, we use this formula with 2,000 as the principal value. The I was the rate they gave us divided by 2 because interest, the rate was 2% for the first time period. So it was 2% divided by 2, and N was the total number of compounding periods during the term, and that turned out to be 11 over 2. And then between 2 years, 9 months, and 6 years, see that 3 years and 3 months had to pass. Then we analyze what happened with the funds by using this formula again, but then we used the value of those $20,000 after 2 years and 9 months as the principal value. And we use a formula again, this time with 4.5% compounded monthly divided by 12, and n, the total number of compounding periods during the second term of 3 years and 3 months turned out to be 39. This was 39. Oops, 9. Okay. So we rely on the same formula. Future value equals principal value times 1 plus I, all that to the n, for 2 separate time periods. All right. Thank you for watching this video. If you have questions, let me know, contact me, and I'll be happy to help you. Bye-bye.